Cans are very convenient, but once they've been had, they take up a lot of space. Going this way, your bin overflows quite quickly. Going this way, and it's not so bad. Or even better, like me and your monster marinated, this can be quite a lot to throw away in a bin. But crush down to this, and it's a lot easier. Conventionally, you get one of these. You screw it in, you pull the lever down, and it crushes the can. And that's lovely, but still requires quite a bit of force. And my other half can struggle with the force needed to crush a can. So, I made this. For this can crusher, what you'll need printed is the upper of the can crusher, the lower, the NEMA 23 motor mount, moving platform, 4 couplers which are screwed onto the lead screw, 2 gears screwed onto the lead screw with couplers as well, 1 gear for the motor itself, a container for all the electronics, a lid for the electronics, and a little button pusher to make sure that the button can be pushed. For the steel, you'll need 2 8mm lead screws, 7 8mm thrust bearings. These 2 come with the lead screw, along with 8 bolts, but you can use 10mm bolts instead. You'll also need more 3mm bolts, all 10mm long. You need 6 with nuts, and then you'll need 8 without nuts. The ones with nuts are for the couplers, and then you need 4 to screw into the motor and 4 to screw on the lid, and of course Allen keys in order to move them. And then for the electronics, you'll need the NEMA 23 stepper motor itself, either the lead that comes with it or 4 DuPont leads, a breadboard to plug in all the electronics, Arduino, ESP32, ESP8266, I'm using an ESP8266 for this, a step-up voltage regulator to change the 12 volts to the 24 volts, A4988 stepper motor driver, a 25 volt 100 microfarad capacitor for regulation of the voltage to the motor, a push button, a barrel jack adapter, so you've got 9mm barrel jack in this side, and then you can put it into 2 wires this side. You'll need a screwdriver to screw in the leads, and 2 leads for those of course, and then a selection of DuPont leads male to male, either like this or the smaller connectors like that. First thing is to put the nuts and bolts just loosely in all of these couplers. You get the bolt and the nut, you screw it in a little bit, just like that, and then you put it through the hexagonal side, because it is a bit of a tight fit. Once that's in, you can unscrew the bolt, that'll stay in there, and then you push the bolt through from the other side, and then you'll need an Allen key, and just screw it in just a little bit. There we are, so you can feel when it's got purchase, and now that's not coming apart anymore. And you just need to do that with all 4 of these, and then with the 2 that go onto the gears as well. Once you've done all 4 of the lead screw couplers and also the 2 for the gears, my next recommendation is just to run them up and down the lead screw a couple of times, just because the thread will go on easier one way than the other, and you just want to make sure that it's easy enough now without having everything else on. And if you find that they're far too stiff, then you may need to loosen the nut and bolt if you may have over tightened them a little bit. They are chamfered one end just to make it easier to put on as well. And the same goes of course with the gear couplers. Now these are easier to go on the wrong way around, as it were, at least to begin with, and then once they're all the way through, it's easier then to start them the other way, which will be necessary later on. Now we'll go on with a little bit of perseverance, and actually it's just trying to break through the end, but that's where it's getting very stuck. So there we are, force it through, happy days. If it is particularly difficult, then by all means screw on one of the other lead screw couplers, one of these, tighten the bolt down, and that'll be better to grip, especially if you have a spanner or wrench to fit around these. And of course, don't forget the gears as well. Again, they're easier done back to front. Now the PLA can be a little bit sharp. By all means wear gloves if you want to protect your fingers when touching the gears. So now they're all done. Next thing is to put the gear coupler into the back of the gear. This is done just because then it's easier to stop the gear from moving. You've got the cutout on the inside there, which you don't have on the gear, just to make sure that the gear runs smoothly, but also then doesn't move up and down the lead screw. Just screw those in, and so it's on a different pitch than the lead screw itself, just so that if one wants to unwind, it gets caught in the thread of the other one. Next is to put the screws into the platform. So these lead screws came with these 2 brass fixings. They slot in. I put them in this way around. They are quite snug, not all the way yet. So I put them so that the big ring is the same size as the cutout. This is because then when it's pushing, it's going to be squeezing this plate onto the plastic, and you're not so reliant on the threads being formed in the plastic to hold it in place. And the reason I don't push these all the way down is because at the moment the holes aren't aligned, so it's easier to move them and then screw in. Now it's up to you. You can either screw them in with the provided longer bolts or with your own shorter 10mm bolts. The thickness of this PLA is 10mm, so if you don't want them poking through the other side, then it's easily done. And then all 8 of these need to go in, and once they are, you can safely push down on the brass and you know that it's all lined up. These bolts can be a little bit difficult to get in the first place. They should be self-tapping. There should be enough clearance for them to do so. If you don't like self-tapping bolts and have an M3 tap, obviously wind that through first and life will be a lot easier for you. And just tighten them up so that it's flush. Otherwise you may have a little bit of a wobble going on. So it's up to you if you want to use the 3mm bolts that were provided with the lead screws, and if you do, then they're going to be sticking all the way through, as you can see there. If you like that aesthetic, then use that. Whereas if you don't like it looking quite so gnarly, then use more 10mm bolts like I'm doing here, and we'll end up using both sides, just because then, as you can see, they don't come all the way through. I dare say it's a little bit safer, but when talking about quite big gears moving with quite a lot of force, this whole thing isn't exactly an epitome of safety. Now that we've done all the prep work, things start to go together. These two little lovebirds will dovetail in together like that, and the idea is that you're going to have 2 lead screws going through with a platform in the middle and bearings and couplers. So that's the first thing to do. So I find it easier to envision where this is going. So this one is going to be there because it's going to be sliding back and forth. Screw in a lead screw, and they'll be going through there. Now, before they go through there, they need the couplers. This is why we screw them on beforehand, so they're easy to get on now. Just put this up a fair distance. It's going to be unwound again soon. And as ever, when you're trying to screw, don't force it. If it's not going in easily, you've probably got a bad angle. And if it's still a bit stiff, by all means, apply some lubrication on it to let it wind in easier. After this, we need the 8mm thrust washers. Come in 3 pieces. You've got a regular washer, both sides, and then the needle thrust bearings in the middle. Regular washer goes on, needle thrust washer goes on, regular washer goes on. Same the other side, washer bearing washer. And now they can be slotted through the 2 holes there. A little bit of wangling to get it to line up properly, it helps. There we are. Push them in place. Wonderful. You'll also need to do the same the other side, but in reverse. So you want your thrust washers on first, onto the end, screw on the coupler. Now the distance I like is for the end of the lead screw to just become flush with the end of the coupler, just like that. That does make it a lot easier to line everything up later on as well. Thrust washer has to go on first, and then you screw on the coupler. And now what you want to do is move these up so that now they are touching at the bottom, and also that there's an equal gap at the top here, slanted too far one side or the other, just to keep everything as parallel as possible. Next are the gears. So again, thrust washers, and now gears go on. I say they're going to be reversed to what we've done before. It'd be a little bit fiddling, and this you don't want all the way tight. You want a little bit of slack so it can rotate both ways, and you'll probably feel it isn't lined up when you first put it on, unless you're lucky. We'll screw on the other gear, gone easily to begin with, and then go a bit tight as it's trying to get through the other side. So we'll back it off a bit, try again, back it off a bit, and this is just because you're trying to get the threads to line up inside. There we are, they've lined up. So that's now easily winding on all the way through the end. Wonderful. This one's still being a little bit of a pickle. Loosen this off some more. Oh, it's going on nicely. It's getting to a point that it's stopping. Can't put it in any further, which means it's just a bit tight. So the easiest way to fix that is to tighten the coupler of the other side. This is what it helps to have it already started. Let's just screw it in until it's tight, and then you can put more force on in order to wind it in. Again, there's a hex around here and flat sides around the couplers, so that if you need to, you can also put on a pair of pliers or a spanner or a wrench or anything like that. Wonderful. So now they're all slightly in. What I like to do now is to line it all up. So of course the couplers the other side want to be through the same distance, and they want to be then tightened. Now the PLA can crack if you over tighten it, but you really have to give it a lot of force to do that, so wouldn't be too concerned about it. You can get this gap pretty much close up as well. It is modelled so that it's angled. Key bit here, when you're screwing in the gears from this side, because this lead screw is most of the force that's going to be the structural integrity that's holding it together. You want to make sure that the gears come up with the thrust bearings in the middle, hard up against the back of the base, and you want to try and keep this all perpendicular. So this is a right angle in here. The reason for that is that if you were to make these looser, then obviously when it tries to crush, it's going to be bending things, and then this is going to bend. And as you can see, it's printed in pieces, so it's going to pop up at the very least, or it could snap something. That's why you want to make sure that it's kept tight, because although it's mainly 3D printed plastic, it is the integrity of the lead screw that is keeping it all tight. And don't overdo it like that, because now you see it's a slight V in the middle. You want to just make sure that it's all flat and makes a lovely right angle. Like that. And then once the gears are in position, try to make sure that the platform as well is parallel in there. And then of course screw in the 2 bolts there. If you don't tighten them enough, then it'll slip when you're trying to crush a can. Easily fixed, just tighten it again. There we are. There might be a bit of a wiggle, but that should be fine. Otherwise, get as close as you wish. Next bit is for the motor. This is the gear, and they're all herringbone gears so that they don't wander off. This is the gear that goes onto the stepper motor. There is a small cutout you might be able to see at the top. It's a bit flat. And there is also a hole for a grub screw if you want to use it, but I find it's really not necessary. However, what is necessary is to make sure that it lines up the right way around. Push the gear in like this, we'll see that it does fit, but if it was the other way around like that, and then try to go in, we'll see it's trying to slide off to one side because it's not the right way around, as you can see from the top. The one in the middle needs to be pointing the other way. Get the step motor, and of course before you put on the gear, you want our thrust washer. The motor is going to be that way. You need to make sure that the gear is facing the opposite way. Pin it on top, we'll line up the flat, and the hole for the grub screw helps quite a lot for that as well. There we are. So the motor goes in this little house, all nice and cozy. These two will slot into the back here as it all drops in. There we are. When one spins, the other will spin as well. Just like that. And that's the very essence of the motor. Next up is the electronics. First thing, this is a step-up transformer. Voltage comes in here and voltage comes out here. And then there's a little screw that you can rotate on here to make sure that you're getting out the 24 volts which you needed. Now I've set this up in a particular way for the button in particular. So what I do is I put the transformer in at the top, and then I'll do similar but opposite with the stepper motor driver, the A4988. And this small screw, you can screw all the way because you don't need to worry about current limitation on a driver this small for a motor that big. So that will then go in the bottom. And the button is the most important bit. You want to position the button so that it goes into row 20 and 22 and over G and I. So essentially the button itself is hovering over 21H, at least on these breadboards anyway, just like that. And so now you need to wire everything up basically. The wiring diagram on the right shows where all the wires should go. So starting off with the 12 volt barrel jack, we see that it goes to one side of the power rail, which I'm calling 12 volts on the right, and the ground goes to the left. We're only using the power rail on the right for positive, and then the common ground is all on the left. So from that 12 volts, part of it goes into one end of the transformer, and again the other end goes into ground. And also from the 12 volt line, it goes to the voltage in of the Arduino clone that we're using. Coming out of the transformer at 24 volts, it goes back to the common ground and it goes into the V motor of the A4988. The ground also goes to the common ground, and along these two as well is the 100 microfarad 25 volt capacitor. Again, being sure to observe polarity. Connected to the stepper motor, we then have the 2B, 2A, 1A and 1B, as you can see there. And then for VDD, for the A4988 voltage, that comes from the 5 volt power rail, and the ground is common ground as well. And this 5 volt rail is of course powered by the Arduino. On the other end of the A4988, we have the enable pin, which is actually tied into the Arduino for once, which is uncommon for these, and that goes to D12. And then the MS1, 2 and 3, which are all for microstepping, they're all connected to the 5 volt power supply so that the maximum microstepping is achieved. Reset and sleep are tied to each other, and then step goes to D11 and direction goes to D10. The button being in a specific place, which doesn't quite show up in this diagram, but
look back at the video, you can see one side goes to ground and the other side goes to D13. And then finishing off is the ground from the Arduino itself. Moving over to the code, we can see that we begin with initializing integers for each of the pins. So we've got the step pin, which is 13, direction pin 15, and the enable pin, which is 12. Yes, it doesn't quite marry up to what you see here for the Ds beforehand, but you just have to consult the data sheet in order to see what I mean there. Then we have steps per revolution for the amount of steps needed for one revolution of the stepper motor, and a step delay, which we're going to use microseconds so that we can have the highest speed. To use a higher speed, you also need to accelerate and decelerate the stepper motor, which we'll see later on. We then have other values, which are all zeros, because they'll be changed later, mainly for loops. And then we also have another integer called m, which is just for the acceleration and deceleration. Then we've got the button pin, which is tied into 14, and a button value so that we know when it's switched. So in the setup, we need to say that the step pin is an output, the direction pin is an output, the enable pin is also an output. I begin the serial monitor, that was mainly for debugging, but I've left it there in case you want to use it for anything else. A small delay to make sure it is serialized. We then digitally the enable pin high, which is what disables the A4988. It ensures that it's quieter when not in use and stops the motor overheating or using too much power. And then the button pin is input with pull up, which is important to note when it is pushed. Now we go through some simple functions. So the accelerate stepper function goes back to the earlier integers. So we're saying that a is 0 to begin with. So now we're saying a is equal to m, and all the time a is greater than the step delay, which is 40. We're going to subtract. And then we've also put in D and T, which is equal to 2 at the moment, just to play these over twice as opposed to just once. So what we're doing here is putting the step pin high and low with the delay of microseconds of A, and that's what is accelerating it. So it's starting off at, we've got the step delay plus steps per revolution divided by 4, so that's 800 step delay, so that's 840. So we're running through and then it'll be 839, but we're running each of those twice. The yield function is of utmost importance with an ESP8266 because that is what stops it from shutting itself off if it's in a long loop. Decelerate stepper is the same as accelerate stepper but in reverse, and again there was the yield function. And of course we need to move it the other way as well. So we've got accelerate stepper backwards and decelerate stepper backwards. The only difference here is the direction pin first is pulled high, and then of course at the end it's pulled low, just to make sure that it's all in keeping. Then we got spin stepper, which we combine the functions. So we accelerate the stepper, the one that we've already seen, and then we've got the use of R here. So this is for I equals 0, I is less than R, I plus plus. We're going to step it high and low, and R we'll see later on, but that was just what was changed in order to ensure that the correct movement is made. And then we put I back to 0, and we decelerate the stepper, so there's not too much back EMF either. Same thing for spin stepper backwards, same as before, except the direction pin is written as high. Now, in the loop, first thing we need to do is read the button value. If we didn't have this, then obviously nothing would work. So we're reading this all the time, and because it's input pull-up, it's going to be as 1 when it isn't pressed, and then 0 when it is. So all the time it's just reading 1, 1, 1, 1, 1, until it's finally pressed, and then if the button value is equal to 0, which it then would be, we put the enable pin to low, which is what turns on the A4988. There's a small delay to make sure that it's definitely powered on. We then have S equal to 57, and R is S times steps per revolution. So the idea is there are 57 revolutions, and then R creates the steps. And then of course we plug R back into the number up here to say I is less than R, so we're going to do that 57 times. Happy days. Well, 57 times 3,200. Serial printed out, again, mainly for debugging. And then there's a small delay at the end to make sure that it's all printed. It then spins the stepper, which is accelerate it, spin it, slow it, and then it stops briefly at the end. We then invert the value, so it's now negative 57 because that's what it needed to spin backwards, the way that I designed it. There we are. And then O is S times steps per revolution again. It tells you that spinning backwards, it spins it backwards. So that's going to be accelerate it, spin it, slow it down, and then delay. And then to finish it off, we put the enable pin as high to prevent the A4988 from functioning anymore. And then we put R equal to 0 to make sure that it doesn't accidentally run this loop again. And then a small delay just to make sure it doesn't all get confused. And that summarizes the circuitry diagram and the code.
So now that we have it all together, you have options, you have a decision to make basically. This is for all the electronics here. So getting to the stepper motor. Now the stepper motor of course comes with its own lead that you can plug in, and then 4 bare wires the other side, and it's a bit long, so if you want to snip it to plug it into the A4988, that's fine. Or if you'd rather use shorter male to female DuPont leads, then that's also fine. However, do bear in mind that the DuPont leads are a little bit loose, so it's not really recommended. final assembly. Now there are 4 holes in the bottom of here for screwing into the motor, but 2 of them are taken up by the breadboard on the top of them. So use them if you want it more secure, but just know that then when you're trying to get it out, it can be a bit of a pickle. If I'm putting it together, taking it apart, I don't use the top 2, I just use the bottom 2, and I find that's more than sufficient because there's not a lot of force being applied on him anyway. So you see in the container lid, there's a cutout at the side here, and there's a ridge at the bottom here. So the cutout here is for the Arduino, or the Arduino clone that I'm using. The ridge down the bottom is to keep the breadboard in here, and then this little turret up here is for the barrel jack. So it can be a little bit fiddly to get in, but we'll do our best. So this needs to slide in the ridge. Wonderful. And then the breadboard needs to come in at a bit of an angle so that it gets underneath, and then it slots in to the bottom. Move these wires out of the way because the barrel jack then needs to slot in the top. This goes on top of this. Easy to line up because the curved surface here is the same as the curved surface there, and then the straight edges. And you want to just line up, in this case, 2 of the holes. So the easiest way I find for that is to drop in the bolts first, which helps if they're slightly magnetic. These are not. There's one. It has all been designed so that you should be able to access the gaps fine. And then if you are just using 2, then you just need to screw these 2 in. So they should fall through the gaps of the PLA because they're only screwing in to the stepper motor itself, which helps tremendously in trying to line it up. It doesn't screw in very far, it's only about 4mm, which is 8 turns with a standard M3 bolt. So now they're in tight, you'll need a little button pusher, pop it in, hold on to the other end, and then line it up again so the curves are with the curves, and this little cutout here is what's going to stop that barrel jack from jumping up and down. Give a chance to find the button, but that's where it's going. So line it up, and then before you screw it in, just press it. So we're happy that the button's being pushed. And then you've got 4 holes for some more 10mm bolts. Again, self-tapping. It doesn't wind through the lid, it only winds through the base, which again helps to line up to where it should be. I find 2 to be adequate. And then all you need to do, slide it in. Can be a little bit finicky sometimes. There we are. Plug this in, push the button, and watch it go.